as well. Okay. Okay. So before we look at other chapters that we have and the activities as well, so let me take like 2 minutes just to demonstrate. 1 minute, 1 minute just to demonstrate what the other guys are supposed to do in case of, any challenge when it's come to download of the virtual machine. So, for Mr. Kane, I hope you can log into your portal. This is your portal, right? Or rather, you can get to this portal up to this point. Is that so? Please confirm. Are you able to log into your portal? Or you have the problem of logging into the portal? Please confirm. Msakin, are you around? On the chat, please. Okay. So if Omsakin is not there, I think, or if he's there and he cannot chat and is listening, this is what you're supposed to do. The link that I'd given you. Remember this link that I'd given you? You just copy the link and you open the new tab, paste it. Okay. You paste that one and you'll get this page. Misakin, I believe you are there. You scroll down and you have these two virtual machines, CyberOps Workstation and Security Onion. You just click the two. So click the first one, you'll be able to download it. Click the second one, you'll be able to download it. So I hope that is clear. Even though I don't know whether you are there, you just logged in and walk away. Okay, which is common to most of the instructors. Okay, but that's how you're supposed to go about it. So now, we're supposed to look at chapter 7. Sorry, chapter 7. So chapter 7 is about connectivity verification. So remember, all these are CCNA work we are still working on. We haven't started now looking at, the CyberOps topics. The CyberOps topics, we are still looking at various CCNA courses. So connectivity verification, of course, after you have set up your network, be it a peer-to-peer network, be it client-server network, be it a wide area network, it's always good to verify the connectivity using various utility tools. Okay, so to help us out, is protocol as ICMP. So remember, ICMP is one of the layer 3 protocols that we have, and it will enable you to do what? The verifications. Internet Control Messaging Protocol. Use ICMP connectivity verification tools. So explain how this ICMP is to test network activity. Use Windows tools, ping and traceroute to verify network connectivity. Okay, so we have both ICMP version 4 and ICMP version 6. You should be able to differentiate these two. You should be able to differentiate these two. Okay. Now, normally, after you have set up your network, verifying your network. So how do you know there is connectivity or there is no connectivity? Through the response that you'll be getting, through the displays that you'll be getting, that is the reply that you are going to get. Whichever sort of output you're going to get will either tell you whether there is connectivity or not. If you get reply, meaning those devices, the hosts are communicating. Request timed out, it means there's a challenge. So that reply and timed out or unreachable, you are getting it as a result of ICMP protocol. So it means if the ICMP protocol is not enabled, then that means you will not get anything. There will be no response. Okay. So the purpose of this messages is to provide feedback about issues related to the processing of the IP packets under certain conditions. So ICMP messages are not required and are often not allowed within a network for security reasons. So ICMP is available for both IPv4 and IPv6. So ICMP v6 is the messaging protocol for IP version 4. For IP version 4. And ICMP v6 provides the same services for IPv6, but includes additional functionality. Okay, unlike ICMP v4. So both ICMP v4 and 6 do have common messages that you will come across, like host confirmation, destination or service unreachable, time exceeded, and route redirections. Okay, those are the common messages that we have with ICMP, okay, v4 and v6. For the case of host confirmation, okay, that is, you want to confirm whether you can get or you can communicate with another device on the network, be it a local area network or a remote network. For our case, we are looking at a remote network where H1 is supposed to communicate with H2. But if you look at the two, they are on a remote network. Okay. So how is the process here? How is the process here? So the process will start from, the layer 2 of the LAN where H1 and the router is located. So they'll start that communications from that point. So H1 and router will be communicating, okay, through layer 2. Through layer 2, okay, just to see whether you can get into that. So ICMP echo message can be used to determine if a host is operational. So the local host sends an ICMP echo request to a host. If the host is available, then the destination host responds with an echo reply. This use of ICMP echo message is the basis of the ping utility. You ping and you get the packets. Ping. Packet internet groupers. Packet internet grouper. So it means you're getting the packets. The packets. Okay, in terms of the reply, how many packets have been sent, how many packets have been received, So you look at the statistics, okay, to conclude, the connectivity or the status of your connectivity, by looking at the what? The status of the output or the statistics that we have. Apart from host confirmation, we have destination or service unreachable message. So when a host or gateway receives a packet that it cannot deliver, it can use an ICMP destination unreachable message to notify the source that the destination or service is unreachable. The message will include a code that indicates why the packet could not be delivered. Okay, and you can see we have various codes or various destination unreachable codes, various destination unreachable codes being specified. Okay, so we have the first code as 0 net, which is net unreachable. It is network related what? Output. Code 0. 1 host unreachable, 2 protocol unreachable, 3 port unreachable. So it's very important to understand that. It's very important to understand that. Okay. So you'll find that for the case of ICMP v6, it has slightly different codes for destination unreachable messages. Slightly different codes for destination unreachable messages. Another message is time exceeded. Time exceeded. Okay. So with this ICMP v4, time exceeded message is used by a router to indicate that a packet cannot be forwarded. Okay. Sorry. A packet actually cannot be forwarded because the TL field of the packet was decremented to 0. So remember, the lifespan of the packet, anytime it crosses the intermediary devices, its lifespan reduces. And normally we said, if you remember in CCNA, that the lifespan of the bits normally is being decremented by 1, 1, 1, 1, 1. Okay, there are 8 bits. So it means if it crosses the 8th router on the network, it means after the 8th one, that packet will be dropped. If a router receives a packet and decrement the TTL field in IP version 4 packet to 0, it discards the packet and sends a time exceeded message to the source host. For the case of ICMP v6, also sends that time exceeded message if the router cannot forward an IPv6 packet because the packet has what? Expired. So IPv6 does not have a TTL field. It uses the op counter field. So different fields that we have on ICMP, rather, on ICMP v6, or IP version 6 and IP version 4. So we need to note the structures for each of these versions of the IP that we have. Op limit for the case of what? IPv6, and TTL for the case of IP version 4. Okay, now for the case of ICMP v6, router solicitation and router advertisement messages being used. Okay, so which message generate from which device? Okay, or which one is being generated or originate from the client and which one originate from the what? From the router. Very important. So for the RS or router solicitation message, it's always a message from the client to the router that it's requesting some, information from the router. Then the router will respond back with those details that it requested through RA. So you just need to look at the content of RA. And normally there are three content of RA that we talked about in CCNA. So with this one, as we have said, remember we have said it has an additional to what? Functionality as compared to ICMP v4. So it has the following, you can see, okay? It has 4 new protocols as part of neighbor discovery protocol. So messaging between IPv6 router and IPv6 device, okay? Normally, actually, we rely on this. We rely on this, okay? Then messaging between IPv6 devices, just the devices, but IPv6 devices only. We have neighbor solicitation message and neighbor advertisement message. Meant for what? Meant for devices. The IPv6 enabled devices only. The IPv6 enabled devices only. So these are the new, okay, messaging that we are looking at being added on our ICMP v6 or IP version 6 rather. Okay. Now, how does the router solicitation operates? Okay. From which point to which point are we talking about here? So in this case, so for RA messages, you can see, okay, for the case of the router solicitation, solicitation here, so we send a message from the host, okay? RA messages are sent by routers provide addressing information to hosts using stateless address auto configurations. RA messages are sent by routers to provide addressing information to hosts using stateless address auto configurations. Slack only. So remember, Slack only is one of the options that, or among options that are provided within the RA. A router will send an RA message periodically or in response to an RS message. A host using Slack will send a gateway to the layers of the router that send the RA. When a host is configured to obtain its addressing information automatically using Slack, the host will send an RS message to the router requesting an RA message. So you can see it's a process. So it means this particular device is depending on the on the Slack option only. Depends on that to get all those details. Okay. For the neighbor, advertisement messages, okay, are sent when a device knows the what? The IPv6 address of a device, but does not know its MAC address. This, you can see, is equivalent to the ARP for IP version 4. So in this case, we are relying on the what? Neighbor advertisement and neighbor solicitation messages. So those are things that we are looking at. Those are things that actually we are looking at. So remember, these are now for the for the IPv6 enable devices that we have. So for the neighbor advertisement messages are sent in response to what? To NS messages, a request from the what? From the device, from the client, that is something that you requested. Yeah? So in return, you are getting the NA. You're getting the NA. So the NA message includes the device Ethernet what? MAC address. This is equivalent to an ARP reply in IP version 4. Then we have DAD, duplicate address detection, DAD. So remember what we said. When you receive a request with the first option, Slack only, or Slack with DCP v6, it means you'll be creating your own what? Your own internal address, your own link local address. After you have created your own internal address, then before using that particular address you have created, you need to find out whether there's another device on the same network using the same address you have created, because that one is also possible. So in that case, the DAD is there now to help you out to see whether that particular address you have created is in use or is not in use. DAD does that. So the DAD is performed on the address just to ensure that it is unique. It is unique. So to check the uniqueness of an address, the device will send an NS message with its own IPv6 address. If another device on the network has this address, it will respond with an NA message, which will notify the sending device that the address is in use. If a corresponding NA message is not returned within a certain period of time, the unicast address is unique and acceptable for use. That's the importance of the DAD, the DAD, duplicate address detections, because you are creating your own address. So ping and trace route utilities is something that, guys, you have used before. Okay. So how do we ping? How do we test the connectivity? Of course, you ping to get the reply. And as we have said, there are various responses that you'll be getting, reply, or request timed out. That actually you'll be getting there. Okay. So with the ping command or with the ping utility, okay. So the type of connectivity test performed with ping are, you want to check whether you can ping yourself, loop back, or ping the default gateway or the remote network. So depending with what actually you'll be pinging. So it's the same thing that actually we are talking about. Okay, the loop back, okay, where you just ping yourself or the PC test itself. You check actually the TCP/IP stack, whether it is what? Operational. So you can see an error message indicates that the TCP/IP is not operational on the host. In case you get an error. And that's why it's important to check that you can ping yourself first before you ping others. The default gateway, the ping can be used to test the ability of a host to communicate on the local network. So normally, again, it's very important. you ping your own default gateway before you ping the other remote devices that you have. Are you able to go through, or are you able to access your own router? Are you able to go through your router? Then if that's the case, then you should be able to reach the other end device. So you just ping from your own network, from the local, as you move out. Just to verify that there's no challenge or there's no problem with your connectivity. Okay, so, and that's what actually they're trying to test. Then again, it's very important to note the default gateway that you have set. In case of any mismatch, or we don't belong to the same network, then always there'll be a challenge. Always there'll be a challenge. I'll not be able to access my own router because of the what? Network mismatch that might be there on our network. You can as well test the remote host, echo request, echo reply. You can see the remote host. Okay, meaning we don't belong to the same network. A remote network is a network that you can reach via what? A packet. Okay, then from there, you'll be able to see the output that you are getting and the statistics that we'll be getting on that particular network. Traceroute and traceat is a very important utility as well. So traceroute applies to, mostly, okay, Linux. You can use traceroute on Linux. You can use traceroute on switch, on a router, on access point. Traceroute, if at all you're using the command line, or if the device is a command line interface enabled, then traceroute will be applied. So traceat is a window utility. It can only be applied on Windows, traceat. So, but both traceroute and traceat generates a list of hops. That is a list of devices that were successfully reached along the path as you move out. This list can provide important verification and troubleshooting information, okay, that will assist you to know which devices are accessible, which one are not accessible, and more so, the routers on the network, the routers that we have on the network. If the data reaches the destination, then the trace lists the interfaces of every router in the path between the hosts. So all the interfaces that it has successfully traversed will be listed for you, okay, on your output. So if the data fails at some hop along the way, the address of the host router, of the last router that responded to the trace can provide an indication of where the problem or security restrictions are found. So you just deal now with that particular what? Hop device, that device, the last device, because it's not able to list it, meaning it's not able to go through it. So there's a challenge with that device. So you start your troubleshooting from that device. Then always the time, round trip time, RTT, that being provided with the output of the trace route or of the trace sat. It's very, very important. So this round trip time for each hop along the path, it actually indicates if a device failed to respond. A device failed to respond. The time it's taking, basically you can just conclude that it's a problem. Because if, it's taking longer to respond, so could be there's a problem with that particular device. Maybe it's a remote device located in a different, region or a different country, depending on the branches that you have. Assuming you have different branches along, or in Africa rather. like Cisco offices that we have in Kenya, Nigeria, Egypt, etc., South Africa. So assuming you want to get to one of those offices by pinging the various devices that are there. So you'll be able to see, because we have various devices or hops that will be successfully listed as you get to maybe to a given office. So if it has taken time to get maybe to that particular office, then that means it's a problem. So normally that's being indicated by an asterisk used to indicate a lost or unreplied packet. So if you get the asterisk, then that means it's a challenge with the network. So this information can be used to locate a problematic router in the path, or may indicate that the router is configured not to reply. It depends. Sometimes you can configure a device not to reply, depending on the sets that or the security features that you have set. If the display shows high response times or data losses from a particular hop, this is an indication that the resources of the router or its connections may be overused. So basically, that's how we need to understand or use various utility on our network. Same things applies to both IPv4 and IPv6. The lifespan of the packet as it traverses various hops or various routers on the network. The first sequence of messages sent from traceroute have a TTL field value of 1, which causes the TTL to time out the IP4 packet at the first router. This router then responds with an ICMP before time exceeded message. Traceroute now has the address of the first hop, okay, as it moves on our network, okay. So you can see traceroute then progressively increments the TTL field 2, 3, 4 for each sequence of messages that are provided there. But the lifespan of the packets, the moment it crosses the router, is supposed to be reduced by 1. Okay, so these are the various codes that, again, you need to interpret depending on the output, because this output, mostly you will get them in terms of code. So how do you interpret each code? How do you interpret each code? So it uses message codes to differentiate between different types of ICMP messages. So these are some common messages codes that you have talked about. Okay. 0, okay. 3, 5 indicates what? 8 indicates what? So it's very, very important to understand the concept of this ICMP, of the various codes that it has, and how actually it will be replying. Okay. So that's basically what I want you to understand with that. So before we look at the lab work, let's look at this chapter 8. Look at various, ERP protocol concepts. Okay, chapter 8, module 8, address resolution protocol. Address resolution protocol. Okay, so let's look at various objectives. So the main objective here is to analyze various address resolution protocol PDUs on a network. PDUs on a network. So we have MAC and IP. So MAC address, which is a layer 2 address, and IP address, which is a layer 3 address. So compare the roles of the MAC address and the IP address. Why do we need the MAC address? Why do we need the IP address? Okay. So welcome, Barak. I can see Barak has joined us. This is the first time you are joining this class. So also we are going to look at various ARP issues that are there. The issues that are there. Okay. So with the MAC address, which are there are two addresses or a physical address, mostly is being used to test the connectivity, within the same network, the local network. So the two primary addresses assigned to a device on an Ethernet LAN are physical address and logical address. So physical address used for Ethernet NIC to Ethernet NIC communications on the same network. If the destination IP address is on the same network, then the destination MAC address will be that of the destination device. Then also we have local address or the IP address used to send the packet from the original source to the final destination. So the layer 3 address. So in this case, we are dealing with the IP addresses, logical address or the IP address, and the physical address we deals with the MAC address. We are dealing with the MAC address. Okay. So how do we get to a remote network? Especially when now dealing with the layer 2 or the MAC addresses. Okay. So it's very important also to understand the Ethernet header structure and the fields. It's very important to understand that. First, for the layer 2 Ethernet header structure, you need to know how it is illustrated. Always it starts with the what? Destination MAC address followed by source MAC address. Then source IP address and destination IP address. So it's always important to understand this. So when the destination IP address is on a remote network, then that means the destination MAC address will be the address of the what? Host's default gateway here. So from A to R1, look at the MAC address of the original source, or the source address. Look at the MAC address of the what? Of the R1. Because you see, in this case, we are trying to get the file server, which is on a remote network. But the question is, how does the physical address or the MAC address behave in this case? So, for example, now you have the source here. 000A, and destination is what? 000C. So when moving from A to R1, it's very clear. The source is 00A, destination is 00C. Okay. Now, how about now when moving from R1 to R2? Now, what you need to consider is the MAC address of the port, incoming and outgoing port of R1 Now, assuming they had given the outgoing port of R1 MAC address here, so when leaving from this point here to this point, it means then that 000C become the source, and maybe let's say 0000D, for example, here become the destination on R1. Now, when leaving this port here to this port of R2, then this one become the source, 00D to maybe 000E. I'm just using those ones as an example for you to understand the concept of the what? The MAC address. So when now leaving from now R2 incoming port now to this one, you can see it will be changing. Okay. So you can see how the MAC address in this case is being represented. So it is not static, it is dynamic. Somebody can ask you to identify the source MAC address and the destination MAC address of that particular packet when it's leaving R2 or when it's leaving R1. But the IP address in this case will just remain that IP address. The source will remain the source, the destination will remain the destination. It will not change. That's what I want you to understand, that particular concept. I want you to understand as the packets being moved from the source to the destination. So how does it change in terms of the MAC addresses and the IP addresses until it gets toward its what? Destination. So again, we have various ARP. Okay, the various ARP over fields or concept that you need to understand. Could Ayuko and Bwana Ayuko? Excuse. Sorry, there's some sort of okay. Work from home sometimes. You'll have to bear with me. Okay, now if you look at now what is being illustrated here. Okay, in terms of the ARP. So remember, when the packets will be broadcasted, or the frames rather will be broadcasted, because now we are dealing with a layer 2 device, a layer 2 device, when the frames will be broadcasted. They are being broadcasted because of the what? ARP protocol. They are being broadcasted because of the ARP protocol. So ARP normally provide two basic functions. Why do we need the ARP? One, to resolve IP4 addresses to MAC addresses. Okay, because you are broadcasting. I have your MAC address. I don't have your IP address. So it means I'll broadcast and get whatever I want from you. Then mapping, maintaining table of IP4 to MAC address mapping. So the mappings of the addresses, that is, it mapped IP address and the MAC address. Within the ARP table, you'll be able to see how that mapping is taking place. Okay, so in this case, for example, if you look at now the diagram that we have, when a packet is sent to the data link layer to be encapsulated into an Ethernet frame, the device refers to what? A table known as ARP table. So we have the ARP table, the PC's ARP table, or ARP cache in its RAM memory to find the MAC address that is mapped to the IP4 address. So the sending device will search its ARP table for a destination IP4 address and a corresponding MAC address. If the packet's destination IP4 address is on the same network as the source IP address, then that one will be indicated within the what? The ARP table. It will be mapped there. Okay. So you can see after broadcast, okay, you can see various pieces that we have will be rejecting. You can see, for example, the request is from H1. You can see H2 is rejecting that, H3 is rejecting that, but look at the other one, H4. Okay, you can see this is mine. I will send back my MAC address. I will send back my MAC address. So it means that it will be mapped within the ARP table with the IP address, with the IP address there. Okay. Then the entries that are within the ARP table will be removed, will be deleted, depending on the technique or mechanism being used there. For each device, an ARP cache timer removes the ARP entries that have not been used for a specified period of time. The times differs depending on the operating system of the device. You can see. Okay. So commands may also be used to remove such kind of entries. After an entry has been removed, the process for sending an ARP request and receiving an ARP reply must occur again to enter the map in the ARP table. So you can see the mapping, okay, what we have within the ARP table or within the ARP cache. The mapping that we have here. Okay. Now you can as well identify that by using various commands like show IP ARP for the case of a router and a switch. Then for the PCs, we have ARP -A. We're going to see various IP addresses and the MAC addresses that we have. So remember, these are the one you are communicating with on your network, the one being mapped. The one mapped in this case are the one that you are communicating with on your network. So it's very important to understand that the one being mapped are not yours, but the one you communicate with on the network. It's like the contacts that you have saved on your phone, okay, are the one you are calling. Same thing applies here. Okay, same thing applies here. You cannot save your own, no? Because you cannot call yourself. You have to call other contacts, but not yourself. So apply the concept, the same concept here when it comes to that mapping of those IP and the MAC addresses. Yes, ARP is good, but it has its own challenges. Some of the challenges of the ARP. Okay. So you can see we have the spoofing and broadcast of this. So when it's being broadcasted, so always remember there'll be a challenge in terms of the what? The performance of your network. As a broadcast frame, an ARP request is received and processed by every device on the local network. On a typical business network, this broadcast would have minimal impact on network performance. If many devices start accessing network services at the same time, there can be reduction in performance for a short time. Okay, and that will be a challenge. And especially when we are sharing the same media, it will have a great impact on your network. Apart from broadcast, we have spoofing. So the hackers is just here, or you are the hacker, and you are connected on that network as well. Your intention is not good. Okay, so it means you'll be receiving everything that you need through that. So the use of ARP can lead to a potential security risks in some cases. So a threat actor uses ARP spoofing to perform an ARP poisoning attack. So it's a technique used by a threat actor to reply to an ARP request for an ARP address belonging to another device, such as the default gateway. The threat actor sends an ARP reply with its own MAC address. The receiver of the ARP reply will add the wrong MAC address to its table and send this packet to the threat actor. Okay, so spoofing is one of the issues of the ARP, and that's why it's not being encouraged. Okay, so that's all about this ARP and the issues that it causes on our network. Okay, unless someone has got a question on the same. Do you guys have questions on what you have covered? Mr. King, you had a problem, you had a challenge, but I don't understand. You're not responding. I don't know whether you are there or not, because I need to sort out your problem. I need to sort out your problem. So I need to understand whether you have been assisted or not in terms of the downloading of the virtual machine, because the other labs that we have will be using the virtual machines. So please let me know. Okay, you are fine, huh? Okay, good. That's great. So this lab, did you guys manage to go through this lab? Did you manage to go through it? Because you need to have a virtual server. Okay, you have not been able to complete the process. That's okay. I hope you'll complete the process. Please, can you take a moment to show how to download the Innata card? Okay, I'll do that. Now, with the link I'd given you guys, this is the link. Allow me again to, okay, or not, don't even to allow me, but I'll post it on the chat. Let me post it on the chat first. That's the link. That's the link. Now, so you can see, okay, I'm just giving you the direct, step of doing that one. Huh? After you have logged in, after you have logged into your account, net portal account, okay, or NetAcad portal account. So basically what you need to do, just a minute, I want to close this site. Okay, so already you have logged in, already you have logged in to this portal of yours. So what you do, what you need to do, you'll just copy paste this link. I'm repeating, already you have logged in. If you want to access that, first log in. Just log in as you do log to your portal account. Log in. After you have logged in, open the new tab. Open the new tab. Then copy and paste the link that you have on the chat. Copy and paste it on the new tab. Enter. The moment you do that, scroll up. You have the two virtual machines, this and this. But for now, we have started with the what? With this one here, the first one. Just click on it and download. I'm not going to download it, but click on it. The moment you click on it, you can see it's downloading down here. But let me pause it because I'm using my bundles, and you can see it's 3.5 GB. Do the same for the Security Onion. It will download. Okay. So as clear as it is. Mutiat, are you sorted out now? Are you sorted? Mutiat, let me know. Very comfortable. Thank you. If you are comfortable. Okay. That's okay. Then if you guys, you are comfortable with that, so what you need to do, just ensure that you have downloaded that particular lab, but remember to go through the first lab. The first lab, you have all these labs in your emails. I'd send you all these labs. For those who are setting up the virtual machine for the first time, please use this lab 115. For those who are setting up that particular machine for the first time, use this first lab. It will guide you on how you are going to install it. Okay. It will give you, that overview of the virtual machine, what you need to understand on the virtual machine. After that, then go through these activities. Now, with these activities from 1 up to 4, that is 4 to 7, no, 4 to 6. You don't even need the virtual machine to do those labs. Some just need the what? Just need your PC to do those labs. But from now 434 downwards, we'll be using now the what? The lab, the virtual lab or the virtual machine to do those labs. And I'll be picking those labs randomly. The rest, but for your case, you'll have to go through all the labs. Go through all the labs. Don't skip any lab. Okay? Don't skip any lab. So you need to go through all this lab. Because remember, you'll be teaching students, and it's always good to go through the labs, and know some of the challenges that you might come across and deal with them. Okay, so when the students have problems or might have problems, so you know how to respond to such kind of problems. And this is what we did back in the year 2017 when we were doing all this. We did all the labs, and it was, it was a requirement from our instructors, Sarge and other, instructors. We are not getting a breathing space for that. Okay, fine. I think that's all. Now, the lab. So as you can see, in this lab, you will use the Linux command line to identify server running on a given computer. Part 2, using Telnet to test TCP services. Recommended equipment, you can see you must have a virtual machine installed. And again, those guys who are installing the virtual machine, remember also to install the Oracle VirtualBox. If you don't have the Oracle VirtualBox, that's the recommended VirtualBox. Is the recommended one for these particular courses. Install that VirtualBox first. Then after that, we are going to install that virtual machine. And that's why I'm saying go through the first lab, 115. It will guide you on what you're supposed to do. I think that's clear. Then part 1, we are going to deal with servers. Servers are essentially programs written to provide specific information upon request. Clients, which are also programs, reach out to the server, place the request, and wait for the server response. Many different client-server communication technologies can be used, with the most common being IP networks. This lab focuses on IP network-based servers and client. Step 1, access the command line. How do you access the command line? How do you access the command line? Okay. Now, you log in or log on to the CyberOps Workstation VM with the username analyst and the password CyberOps. The account analyst is used as the example user account throughout this lab. So mostly be using the analyst. And some are automatically, when you log in, automatically will be appearing. You don't have to type the username. You just need to do what? Just to have that. Okay. Okay, you can see there's a Wireshark. Okay. For labs, okay, we are behind in labs, but we are ahead in nodes. I'll take you through that one. There's no problem. Wireshark, chapter 8. We are still lab 4. I'm just picking those labs randomly. So I've just picked this the lab I've picked in this chapter 4 because you can see there are a lot of them. Okay, I'll also do some labs with Wireshark when it's come to chapter 8. So don't worry, Winnie, we are going to do all those labs together. Don't worry, we shall work them out together. Because we'll find that again, with the virtual machines that we have, you'll also need to have the what? The security union at one point to operate on those labs. So I think that's clear, Winnie. Don't worry, we'll do them together, those labs. We're just coming to it. We're still looking at lab 4. Then see lab 5 and see what to pick, what to do with you. I'll have to demonstrate those labs as we move on, but not all labs in chapter 4. I'll only pick one. That's the instructions that we are following from the organizers of the training. You pick one lab, demonstrate, then let them do the remaining labs at their free time, with their ample time. Okay, even after this training, you'll have those labs on your account. So thank you. So now, so I need to log in. I need to log in, but before logging in, already I'd logged on to that, but let me close this and start again from the scratch. Okay. Okay, so you open the virtual Oracle box. Okay, so you can see among the VM installed, you can see there are several VM installed, but it depends with the activity or with the course. Some are for the DevNet, the one I was training last 2 months ago. I was training DevNet, and that's why you can see I have DevNet virtual machines as well, including the virtual router. Yeah. So yes, you can see a lot of VM on my Oracle box, but don't worry, because others are for other courses that I was doing before. Not necessarily for this one, others for the VM for other courses I was doing before. Okay, so for my case, I'll click on this CyberOps workstation and start. The arrow button is here. This arrow, the green one for starting the virtual machine. Click on it. Okay, then give it time to boot. Give it time to boot. Okay, just give it time to boot. Don't press anything. Okay, so you can see username analyst already is there by default. Okay. Then you have the password CyberOps. CyberOps. Login and wait for the process to be completed. Okay. Okay, can just close these ones. Okay. So this is the, the desktop of that virtual machine with various icons. So those who have gone through the first lab, 115, at least you have interacted with those icons as per the instructions that were given there. Okay, including the application app here menu of the virtual machine. Okay, so just go through the first lab 115 and interact with various icons, various features that are being required. Okay, then for connectivity, you have the browser as well. You have the browser already installed on the virtual machine. Okay, so with this browser, you should be able to, with the browsers, you should be able to search for anything that you might want. Okay, let's say like Google. Okay, I can see this connectivity. And that's remind me, for those who are installing that lab today, let me give you also this code that you will, okay, execute on the command line of the virtual machine. Let me paste it. If you'll not be able to have the connectivity, then that's what you're going to have on the terminal window. Just type the way it is and enter. It will reset all those GCP services and you'll get the connectivity. So remember that one, guys. For those who are installing it for the first time, you need that one as well. Okay. So you can see we have the connectivity, whatever you want to do. Okay. Just type whatever you want to type. And you're going to have your connectivity as well. Okay, fine. Okay, so to access the command line, click the terminal icon located in the dock at the bottom of VM screen. Okay, that is the terminal emulator opens. So just go back here. We click on it. It is here. Click on it here. Okay. Or alternatively, you can open it from the application menu up here. You click on the application menu and click terminal emulator. It's the same thing. It's the same thing. Then after that, okay. Then, okay, step 2, display the services currently running. Many different programs can be running on a given computer, especially a computer running a Linux operating system. Many programs run in the background, so users may not immediately detect what programs are running on a given computer. In Linux, running programs are also called processes. They are also called processes. Okay. So note, the output of your PS command will differ because it will be based on the state of your what? CyberOps workstation VM, the PS command. The PS command. Let's just type that PS command and see what we are getting. PS command. Okay. So you can see it's a command that displaying the processes that are running, including, you can see various services, the process ID of the various services that are given here, like TTY, all these are some of the services that we have there. But let's go into detail on that. Okay, here, down here, use the PS command to display all the programs running in the background. Okay, now, first, you can see with that PS alone, the one that we have, this one here, PS, let's include hyphen, this one, ELF, to see all those all those programs running. Okay, you can see. But now with this output, yes, you might find that not all outputs are being displayed. Let me maximize this. Not all outputs are being displayed. Some cannot be displayed because of their administrative rights. Because of them administrative rights. And that's why you must log in as an administrator. In Linux, you log in using the command sudo for the super user. So have sudo command so that those services which cannot be displayed will be displayed, because now you are logging in with the rights. And you can see with this one, you are being requested to have what? The password. For the previous one, there's no password being requested because there you just log in as a guest. But this one, you'll be prompted because now you are logging in as an administrator. So always have the password CyberOps throughout the course. CyberOps. Okay. So you're going to have a lot of processes running, as you can see. The process ID here. Okay. The process ID, the user ID. So this is the user account, the root. Okay. All this being displayed, all of them, as you can see, being displayed. So all these processes are running. Okay. So, okay. So you can see with that, let's just scroll down. So this is the same output that we have. These are the same output that we have. Okay. Then, so there's a question there being asked. Why was it necessary to run ps as root, prefacing the command with sudo? Okay. I've just said it. Okay. For it to display all the processes that are running, but with the more rights assigned as the super user. So the processes that are running, okay, and the one that were not displayed, or the one that are hidden, will be displayed for you as the administrator or the super user of this particular VM. As the super user, you will see more services, more processes which are running, unlike when you are logging in as a guest. That's why the word sudo must precede that command. PS, okay, hyphen EGH, just to understand basically what is happening. I mean ELF, just to get to know some of the programs which are running at the background. Remember, these are the programs running at the background without the what? The user knowledge. Without the user knowledge. But you want to check all this. So it means various services which are active and being executed by the users will be displayed here. Fine. Let's move down. So in Linux, programs can also call other programs. Okay. Programs can also call other programs. The ps command can also be used to display such process hierarchy. You call other programs. Choose -EJH options to display the currently running processes tree after starting the NGINX web server with elevated privileges. So the process information for the INX service is highlighted. Your process ID values will be different. So let's see. So we need to have this command sudo, all this. Unfortunately, you cannot copy paste this, huh? I don't think so. Let me see whether I can copy paste. You can't copy paste this. You can't. Okay. You can't copy paste. Let me see. Okay, you can see you can't copy paste anything. So you'll have to type it the way it is. So sudo, okay. The command is sudo user has been. Then with that service, okay, which is a service, rather a browser that enable you to quickly search any program that you need. For those who have used this particular service, NGINIX, okay. Then you log in CyberOps, so you have more rights. So CyberOps, or what is it? It's something I've not typed right. Oh, I'm supposed to move. Sorry, that I is, this I is not supposed to be here. Okay. Just a minute. Sudo user, is it? Sudo, oh, sorry. Okay, user has been what is it? Command found. Command not found. Oh, it's not there. But whatever I had written, yes, but that one is not there. I'm supposed to remove that E, enter. Okay, so, okay, now that means now you have logged in and you have all these rights as all these privileges as the super user. Then after that is when now you come up with this to see all those processes which are listed. All those processes which are listed, sudo sudo, okay, ps hyphen ejh, okay, and you can see various processes which are listed here. Various processes which are listed. So the process ID, the program ID, all this being listed for you. Okay. Because of the privileges that you have been given or you have used. Okay, so all these are the services which are running at the background. All these are the services which are running, or you can as well call other programs as well, be displayed. As you can see what we have. Okay, so how is the process hierarchy represented by PS? How is the process hierarchy represented by PS? What can you note here? Based on the output, anything you can note? Anything you can note here? Or you can just go back to the virtual machine and look at it from there. Okay. What can you note based on the hierarchy that we have? The display. How is the display? How is the display? Especially the last part, the command part. What can you conclude? The display in this case is in what? Indentation. The way they have been indented here. Okay. The tree, the way they have been indented. The output, huh? The way they have been indented. Look at this. Look at this. It means others has these are a sub process of the others, huh? Others are just a sub process of the others. Okay. So that's what you need to note, huh? That with this one, we have that indentation of the display. The indentation of the display. So as mentioned before, servers are essentially programs often started by the system itself at boot time. The task performed by a server is called a service. In such fashion, a web server provides web services. Okay, so we have the netstart or network statistics command. It's a great tool to help identify the network servers running on a computer. So the power of netstart lies on its ability to display network connections. So note, your output may be different depending on the number of open network connections on your VM. In the terminal window, just type netstart and see some of those network connections and their status. Various protocols. Okay, as you can see the addresses and the status. Huh? So let's see. Netstart, network statistics. Netstart. Netstart. Oh, sorry. Netstart. Netstart. Okay. So look at the various network connections that we have after issuing that command netstart. Okay. Just look at what we have here. As they have said, we might have a different output based on our connection. Based on our connection, we might have different output. So look at that. Then after doing that, my friends, so they want us to do what? Okay, as seen above, netstart returns lots of information when used without any options. Many options can be used to filter and format the output of netstart, making it more useful. So remember, even in our routers, etc., if you just say show IP protocol or show IP interface brief, it will display all the interfaces of the status of the interfaces that you have. Whether they are up, whether they are down, they'll be displayed. But how about if you want to filter a specific, interface, the one which are down only, the one which are up only? Okay, so we need to include a certain character that will enable us to have such kind of output being filtered. The pipe character, the pipe character. So same thing also applies with the Linux, that when you want to have a specific output, then there are specific commands that you're supposed to have there. So in this case, for example, use netstart with this. Let's start with these initials, tunap, for various initials. They're just various characters. T stand for what, U stand for what, N stand for what, A stand for what, P stand for what. So -tunap options to adjust the output of netstart. Notice that netstart allows multiple options to be grouped together under the same sign. Okay, under the same sign. So the information for the NGINX server is highlighted, okay, after issuing this. So let's see, okay. Let's see what we have first. Okay, so sudo, remember as a super user, okay, netstart, tuna, okay, enter, then CyberOps, okay. So you can see this one has been filtered based on the initials that we have put here. Based on the initial that we have put here. Okay. With T or -T or T in this case, which is a protocol, a TCP protocol, as you can see here, indicating that it's a TCP protocol. U for UDP protocol. Okay. Then the numeric port numbers assigned. Okay. The socket, remember the socket, a combination of IP address and the port numbers, the numeric, and all the processes which are listening, or the ports which are listening, all, A for all, the process P, okay, in this case. So this one has been filtered. This one has been filtered. And you can see, again, look at various process ID that we have. And that's what they were saying. Perhaps what they have on the lab here might not be the same. You can see, might not be the same with what you are getting, because of the different network connections that you have. So don't worry. Don't worry, because that one will be determined by the network that you are in. Okay, fine. Then let's scroll down. Okay. So okay, so this is what we have. This is what you have. Okay. So they want you to do what? So what's the meaning of the -TUNA? That's what I've already talked about. Okay. But if you want to get more of those initial in details, then what you need to do is you just need to have the manual of that network start, manual of net start, and you get all the meaning of this. Man net start or manual, man for manual. Let's go to the manual of the net start and see what we have there. Okay, so man net start, the manual at, okay. Then you can see the output that you have there with various initials that are being given. So let's start. Okay. Print network connections, routing tables, interface statistics, masquerade connections, and multicast memberships. So if you just scroll down, you should be able to see all this. Okay, they are here. Okay, you can see all these are given. Okay. Okay, like hyphen A for all, show both listening and non-listening sockets with the interfaces options. Show interfaces that are not up. Okay, so you can see hyphen F, C, but ours is a bit specific, huh? So we need to check. They were saying hyphen what? Hyphen T for TCP, U for UDP. Okay, some you get them up here at the very beginning. You'll get them up here. Some those initials. Okay, for hyphen N, it shows, you can see numeric addresses instead of trying to determine symbolic host, port, or usernames. Okay, V. Okay, you can see all this being displayed here for you. R. Okay. Okay. You can see some are even up here for TCP, T, UDP. Okay. So we have small u and capital one. So you need to note the difference between those two and what each represents. So they are all here. You get everything here that you need. Getting to the manual of that, NetStart, you get everything. A minute, I just put my file on power. It's running out. Just a minute, guys. Okay, let's proceed. So basically, that's what you need to understand. So with these labs, normally it's very simple. Just follow the instructions that they are given and be able to work them out comfortably. Okay. So what's the meaning of that? Okay, that's what you have said. Is the order of the options important to NetStart? No, the order is not important. The order is not important. Okay, because if you look at what we have here, okay, there's no order. There's no order, or rather the alphabetical order in this case that we need to follow. No, you just need to note each initial with what it represents. That's what is important. Huh? That is what is important here. That is what is important here. And that's what you need to note. Okay. File. Let's proceed. So clients will connect to a port and using the correct protocol, request information from a server. The NetStart output above display a number of services that are currently listening on specific ports. Interesting columns are, so the first column shows the layer 4 protocol in use, UDP or TCP. The first column here is this first column, this one. Okay, let me just let me open it on the other end. I don't know whether I can get it back. Okay, I can quit that part. Okay, this one here. This first column indicating the protocol, the first one. The second one, the receiving and the send packets. Okay, 3. So 1, okay, sorry, 1, 2, 3, 4, local address, 5, foreign address. Okay. Are they 5, 6? Okay, how many are they? 1, 2, 3, 4, 5, 6. Okay, the state. And the 7th one is the process ID for various processes which are running on this. Okay, so the first column, as you can see, it shows the layer 4 protocol. It's either UDP or TCP. The third column about the what? The address, the source port address. Okay. The source port, I mean the port, it indicates the port address, display the local IP address. The local IP address. Okay. This one here, the local IP address. Then we have also the fourth one. Okay, for the display the address and port of the device on the remote end of the connection. This one here, the foreign address for the remote one. For the remote one. Okay, then the other one, the state, the status of the connection. The status of the connection there. The fifth column display the state of the connection. And the sixth column display the process ID. Okay. Responsible for the connection. It also displays the short name, which is associated with the process. Associated with the process. So based on the net start output shown in item D, what is the layer 4 protocol connection status and process ID of the process running on port 80? So let's move up. The one highlighted. The one highlighted. So they want you to define, okay, or to state the port numbers, give them the port number, I mean the protocol, give them the protocol, the status of the connection and the process ID running on port 80, running on port 80. Which one is that? Based on the output above, here, the one they have highlighted. So what's the protocol? Please on the chart. On the chart, what is the protocol that we have there? The status of the connection and the process ID, please on the chart. The one highlighted in yellow, the one you can see on the screen. I'm waiting you guys to respond. The one highlighted here in yellow, please give us the protocol. Give us the protocol, the status, and the process ID. Am I alone in this class? I can see there are 7 people. I can see Adiru, Rashid, Ahmed, Abu, Lamin, if you are there, Mutiat, you are there. Winnie, you are there. Sakin, you are there. Okay, let me see. I can see somebody else. Thank you, Winnie. The protocol is TCP. Thank you. Okay. How about the status? Okay, let me just go back. What was the question there? That is, you're supposed to, okay, just a minute. Okay, they want to know the layer 4 protocol. That one is TCP. That's okay, Winnie. So how about the connection status and the process ID? Those two. Connection status and process ID. Let me move up for you to be able to see it. Okay, the one highlighted for port 80. For port 80. So can you give the process, the connection status and the process ID? So the first one is okay, TCP, that's okay. How about the status? Listening, thank you, thank you. And the process ID, 395, thank you. How comes only Winnie is the one responding? How about the rest? You've just logged in and walk away or what? How about the rest? Only Winnie is the one responding. How about the rest? Does it mean you are not getting anything? Does it mean you're not following? Oh, it's very discouraging. Instructors, this is very discouraging. As the instructors, it's very discouraging. So that means I'm not going to proceed because there's only one person responding to my questions. So please, can you complete the rest? Okay, can you complete the rest? Because we're supposed actually to, respond based on the output that are given there. What is being asked is what I highlighted above. So we don't have even to go through the VM. Okay, we are just using what they have up here to answer the questions that are given down here. So please, guys, can you complete the rest of the activity? Meanwhile, let me give you another activity you're supposed to go and do. Okay, let me see. Let me see. I've just done 3, 4, 3, 4. You can as well do log files, locating log files. Locating log files. You can see also you need the virtual machine. And please do everything. You don't have to do one and wait. Just do everything. Just do all the labs for your own benefit. Okay, just do all those labs for your own benefit. So the remaining 2 labs of chapter 4, do all of them. Okay. Then the next lab will be about Wireshark. You can see maybe Wireshark. So Wireshark start from chapter 5, introduction to Wireshark, as you move on. So I'll just pick them randomly. Wireshark, maybe check the Nmap as we move on. Huh? Okay. So there's only one lab in chapter 8. There's one lab. We look at it. That's the only lab that we have in chapter 8. But it's about Wireshark. But Wireshark is starting from here, chapter 5. Okay. But if you want to get them better, please don't wait until we are in the class. Just work them out. So remember, we are meeting on Monday. Monday, we'll be meeting. Our next class will be on Monday. Our next class will be on Monday. Same time, same place. Same place. That is where you are. Where you are currently. Okay. And unless you'll be changing your location, but we'll be meeting on Monday. So remember, the chapter exams are active. Please feel free to go through them. Okay, you can do up to where we have covered if you have time. So let me stop sharing. And that is it. Unless you guys, you have question, anyone with a question? Anyone with a burning issue? Okay, by the way, guys, I'll send you all the PowerPoint notes that we have covered. I'll send you all the PowerPoint notes that we have